Alright, let's give it a try. It's my first video ever. I wanted to do a stream, but the problem is that I couldn't get YouTube streaming to work, and I don't really understand Twitch that much. So I'll be doing this video recorded, and I assume that for the first few videos of mine, nobody's going to watch it. So it doesn't really matter if I do it live or not. And I could just later on edit and upload it to GitHub. This also may have some safety measures, so that I don't accidentally open something that I don't want to show to the public, like for example a private key or something. And I need some practice before I can actually comfortably live stream the coding process. Also, I don't know how it would look like when you watch my stream, because I've never done something like this before, and I've never coded when I am when I have to speak. So it's going to be tough, but give me some and I'm going to suck, but just give me some sort of tolerance. Yeah, it will be much appreciated. So before I start, you must be wondering what is Dust? And basically, sorry, that was a very noob question. Basically, Dust is a project by us at Parkour Labs, and at Parkour Labs we are just a bunch of college friends trying to build cool stuff together. And it's mostly written by my friend Bridgecat, who is currently very busy during the middle of semester. I'm doing internship, so I have a lot of free time to work on the Dust project. Let me take a sip. And essentially the problem that it tries to solve, let me just try to navigate to parkourlabs.io, is that two problems. The first one, we call it fearless local first, which we hope you don't try to associate with Rust. It's definitely inspired by Rust. But the idea was that when we were picking a database for the previous apps that we built, so previously, prior to Dust, we were primarily focused on building an app called Dynode. And it's actually this is actually the website for version 1 of Dynode. It's not loading somehow because we used Flutter Web for it. It's pretty lame here right now, but if we actually go to we'll be able to see yeah, so you'll be able to see that this is a note-taking app that we built. And in building this app, there were a few issues that we wanted to address. One of them is to be able to create the app local first, because you don't want a handwriting app to require persistent stable connection to the internet. A student may be hopping around, and you may be out in the wild and just want to doodle something, and if you lose connection and your app doesn't work, that is not acceptable. And but we went on for search for different database solutions, and the primary one, which we are which is most established in the Flutter ecosystem, is Google's Firebase. The issue with Firebase is that although it's very easy to use, it sort of lacks this local capabilities. It does allow you to have some local caching, but it's mostly just caching, and you don't really have any write capabilities to it. And we need to we cannot just make you read something when you're offline. You have to be able to modify your documents when you're offline. So that rendered it impossible for us to pick. And so we ended up decided on the database called Isar. This is an awesome database if you haven't tried out it before. It's written primarily in Rust, and it's providing a Dart binding. And in the implementation of Dust, we actually took a lot of inspiration from the Isar project as well. We learned a lot from reading through the Isar's codebase, especially a lot about how to set up the foreign function interface. And let me just pull this up really quickly, and it's something that I want to show that's super fun. So Let's go to Isar's GitHub page. Wait, what does it say? Oh, okay, only thing. Yeah. So let's go to Isar's GitHub page. And if you actually look at Isar Flutter libs, which is where they host their like native binaries, and inside this package, inside the iOS folder and inside the classes. And I remember there is this binding.h, and you have this function declared here in this header file called isar_get_error. And if you actually open to here, you see that they actually call isar_get_error with 0 to prevent from tree shaking. And that was a problem that we faced when we were trying to deal with like foreign function interfaces and to Rust and try to compile the Rust binary to merge it with the Flutter codebase, because somehow our static libraries were just never able to be found when we ship it, and the result was that actually the compiler was thinking itself as very smart, and it basically did some tree shaking and shaked off the binary that we tried to add in. And it was only until like when we find here that we were able to solve this problem. It was super funny because yeah, it took us a lot of time to arrive here. And so Dust is basically, the idea of Dust is that we want to solve the problem where like the mature solutions basically are only based on like either local only or require a cloud connection. And we want to have a database that's designed from ground up that basically supports local first development. And when you want to use a cloud to provide you with the cloud capabilities. And that was what we were developing for the app project Dynode. As you can see from here, Dynode hasn't been updated for a long time. That's because like we have been quite busy, and yeah, we didn't really like have much of like spare time to work on stuff. And now that we decided that we wanted to focus on the Dust project, Dynode will probably also be put on like a longer hold. And we are actually probably thinking about releasing Dynode to the public under a GPL v3 license, so that people can study the source code and help us contribute towards the project. Because realistically, if we are focusing more on the database layer, it's very like hard for us to actually spare some attention to implement what we call as implement Dynode, basically. And coming back to the Dust project, other than the Firebase, which I mentioned, the Isar, which I mentioned, Isar is a local-only database, so it doesn't support cloud sync, and we need to manually implement sync, and that's very difficult. Also, Isar has some like recent update issues with like migrating to v4, where the author of Isar, Simon, I think, was too busy with his own projects, like from work. So he doesn't really have much time to attend to Isar. I believe that the Isar community is strong and they will be able to figure it out. But sort of like was stuck there. And we wanted to have this database that allows like, that's like automatically synchronizable. Waiting on Isar for that is probably like going to take a little too long, and we don't have any control over that. So that's also like part of the intuition why we designed Dust. Of course, you may say that, wait, isn't there AWS Amplify? Like the AWS and doesn't it support Flutter? And my answer to that is yes, of course, there is AWS Amplify, but the problem is that it's probably the worst pieces of software I've ever seen. I'm just going to say this very straight, that they over-advertise on what they can deliver, and they under-promise, they under-deliver a lot. So with AWS Amplify, they say that you could use data store like synchronizable and everything, and you think, this must support a lot of platforms, right? But with their like more features with their data store, and if you which provides this local caching and local writing capabilities, it actually only supports mobile. And that's not the worst part of it, because the data stores API is similar, but not exactly the same as like the API. And you can sort of like generate the corresponding models and call them AWS API to sort of fetch what you want to do. The problem comes with like the code that it generates. I don't know where can I find something. Let me just create a new folder or something like that. CD developer personal. What was I about to say? Okay. Yep. Okay, this is probably terrible naming, but whatever. So let me just zoom this larger so that you could probably see better. The problem with the problem with Amplify is that when you try to call like the API, which is called amplify.api mutate or some mutation or something like that, and you pass in the model that's generated from Amplify, and you do the query request. The query request in the GraphQL doesn't include something called this version, and this version thing so it won't actually query the version for you from the backend, and the version thing is necessary for like the AWS Amplify to sort of like do synchronization, because the way that AWS Amplify synchronizes the local data with the remote data is through the comparison of the version. And you would think that implementing this thing is quite smart, but actually they did like a very dumb version of like a synchronization. I don't know if I could find it here. So AWS app sync strategies. Yeah, let's just look at the conflict detection. I'm not sure if it's here. And we could see auto merge. And the auto merge, you would think that implementing something from a company as sophisticated as AWS would be very sort of like smart, and they would be able to handle the cases in a reasonable fashion. But this is super retarded in the sense that AWS, as I mentioned, maintains a version for each item, and every time a modification happens on the server, it sort of like bumps up the version number by 1. And the way that synchronization is handled, like by default, is that if you change a model and you send it to the remote server, and it will compare the version code on the remote server to your local app's version code. And if the version code is a conflict, it's not the same version, then it will basically means that like your local data is outdated, and it will basically prompt you to write what's like a sensible way of basically will prompt like a sensible way of resolving this conflict. So there are two as you can see here. There are three ways of managing them, I think. One of them is auto merge, and auto merge, like you may think that it looks smart, but it's actually pretty stupid, because when you encounter a conflict on a list, what will actually happen is that the list will so. Let's look at here. So I have a model, say that a stroke, because we built Dynode before, which is a note-taking app, and the stroke has a list of points, right? And now suppose that you want to sort of add a point to a stroke, and your version code is conflicted, and what will actually happen is that And now, suppose this is like the stroke that you get from the remote, and you sort of like s.copy with or whatever, because it's also like amplify also requires immutable data, so it's kind of stupid the way that they design this API. And so you need to have like points, whatever. This is like probably wrong, but you get the idea and work. So old points s dot. And for those of like new Flutter developers coming here, like this way is basically a dot develop, like to expand the points list. Sorry. So you do this and you try to save this to the cloud. This will create a new S, and you try to await amplify dot API dot whatever request that saves this in the result. What you would end up happening if there is a conflict is that you will have PT1, PT2, PT1, PT2, and PT3. Because there is a conflict, the auto merge will just automatically append two lists together. And that's plainly stupid, because we don't want this to append. It's very clear that we want to add a point here, but somehow you will just append things together. The issue with API, from the way that I understand it, because I have not really looked into this issue in a while, is that with API, it doesn't have this version code query down for you. So every time you try to push to the remote cloud, there will be a conflict, because the data that you push there doesn't contain a version code. And of course, when it doesn't contain a version code, the version code will be in conflict with the version code on the cloud. So what ended up happening is that like every time you push, like if you have some modifications of a list, the list would like basically grow like double its size with a new element in the end. And you add one, like a double its size with a new element in the end. I could never understand why like we have some like APIs that are designed in this way. And it's not really sensible for like a lot of front-end developers as us, like to write Lambda and complicated conflict resolution strategies. And oftentimes the issue that I have with cloud is that oftentimes you have to learn the cloud, sort of they diverge away from like the basics of programming so much, and you're basically just trying to learn the complexity created by other people. And what is the likelihood of when you try to first like found out like AWS amplify, and this is that it's local first and synchronizable, that you're going to dive so deep into the documentation that like you sort of find like it's that in the data store under the most features under the setup, that when you add the dependencies, like that's only where like you can see where like it mentions like supports only mobile. And what are also the likelihood that like you're going to find out the conflict resolution is going to duplicate something when you call it via API if you enable it, and if you disable it, data store is not going to work. So like you sort of have to been through a lot of like the problems to see like those complicated systems, the pitfalls of them. And once you discover, welcome, congratulations, you are too late. You already spent a lot of time on the project. So I don't really want to mention Amplify. I think it's like literally like the worst pieces of code ever written. I don't mean to say this to offend anyone. I know that the Amplify team may be working really hard, but I state my opinions. And the other issue with Amplify is that Amplify allows you to sort of write GraphQL, so GQL, I don't know. And so what happens is that it doesn't anywhere prevent you from writing interface something, but it will, and then you have like a type some other thing implements interface. And it won't generate the interface in Dart. So basically, you are just trying to write an interface, and that does nothing in the Dart side. On the Dart side, and when the code generation runs, it doesn't warn you. It doesn't tell you anything until you push your deploy and you run, and then you realize, oh shit, it doesn't generate anything. And this is especially hard if you're like not the person in charge of the backend. Like if you're working with someone else and someone else does the backend, and you thought it would work, and when it finally turns out to your hand it doesn't work. So if I could have one piece of advice, it is to stay away from AWS Amplify. And So coming back, I probably diverged a little bit too far, but our first approach is idea is that we want to be able to enable you to build local first software fearlessly without ever worrying about synchronization. The synchronization portion of our code has not yet been written yet, but we're basically trying to build an AP database. And let me just say AP theorem. Sorry. AP theorem. AP database basically guarantees availability and partition tolerance, in the sense that the database will always be available for you to read and write, and we will always be able to allow you to persist. What we won't have is that we won't have strict linearizability. It's a quite involved concept, but I'm not really much of an expert there yet, I hope. So the first problem. And the second problem is with state management. We realize that state management has been a huge issue in the Flutter ecosystem. This is especially hard because it itself is already very involved. And the issue that we have with state management, let me just quickly open my phone, is that with state management solutions of Dart, you usually choose to work with the stock ones, where you work with the state management solutions that come with you. And the problem with most of state management solutions is that they use a simple equality to check whether if things has changed. Therefore, it requires you to have data immutability. Otherwise, you won't be able to perform that check. And if you don't have data immutability, then it's very hard for them to understand. And here is a basic example that I wrote and tested in Dart. Actually, we can run this test very quickly in a bit. So with common data mutable data structure, what we do is that when we want to add a point to the list, we just call list.add, right? And you add an item, and we notify the listeners, which is basically all the function that subscribes to this change notifier. And it's a pretty simple approach. And with the other one is that with almost all of the state management solutions that I see, what they do is that they ask you to create a copy of the list and then add the item in the end. So this is the way that they ask you to do, because this will create a different instance, and this instance is different from the old instance. And if we actually look at value notifier Flutter GitHub, sorry, I probably should have prepared all of these things, but we can look at Flutter and lib, and we can probably find something like animation. Nope, it's not in animation. Foundation? Would it be in foundation though? Value notifier. Let me just search for notifier. Definitely it's not in Cupertino and not in material. And gestures is not relevant. Rendering scheduler? No, I don't think that's. Let me see value notifier. Yeah, so now we have the value notifier. I don't know if I could manage to find the code here. Oh yeah, I should have gone this route. And if you look at the value notifier set value, it does this equality check. If this is equal to the other value, and if it isn't, then I'll return. Otherwise, I will notify the listeners. And this equality check basically is Flutter ways of preventing excessive re-rendering if you're actually having the same instance. But for us, like when we add a point to the list, we wanted to notify re-render, but it won't notify because the list has one more point added to it, right? And the idea was only to create a new instance, because this equality in Dart compares whether if the left value on the right and the value on the right are the same instance, unless you override them, or like unless you have some primitive values that will get compared by the value. So as a result, like this is a way to trigger a value notifier to work. And if we actually look at this, it's quite much more laggy than the one on the left side. As this can be seen, this is a GIF. It probably isn't the most intuitive show, but I think I could cd into perf test. And let's just do a flutter run dash profile dash d macOS. Do Chrome or macOS user is fine. It's going to run much slower on the Chrome though, but doesn't really matter. I wonder how long I have like recorded this video, but oh, it's 26 minutes now. Well, I don't know if I'm still be able to like do any like maintenance of migrating to the freezed API, but it's going to be worth it. So this is adding, I remember, 10,000 points using the left. I mean, the names are not perfectly making sense, but the left is a mutable one, so we can click add, and it's a little bit slow, but click add again, and you see that it's a little bit slow, but it works. And if we navigate to the right and we click add, and it's also a little bit slow, but this time you can see that it's much slower, right? So in general, like on this one, it's much faster, where on this one, it's much slower. You see that this is like barely even working right now. I don't know why my Chrome is so slow. Let me just try run it on macOS, and we'll be able to see the difference clearer. Let me take a sip of water. Okay, let me just open it. All right, so this is on the value notify, which is the immutable data structure where we explicitly manually can't notify listeners. And this one is more like the implicit automatic one that performs the changes. So we add a random offset, very smooth. And let's look at here. Add a random offset. You can see like it's much slower. Now it's even slower, and now it's much slower. And if we actually navigate here, add random offset, works still fine. And here, barely even moving anymore, and it will take a lot of time. And this makes sense to you because at the end of the day, if you study computer science, right, and are aware of big O notation, this is an ON squared solution, which means that it's effectively going to be slow. Like, however, compared to this is just an ON solution if we amortize it, which is obviously faster if you have more data. And the reason that most state management solutions choose to sort of use the immutable data structure is that in modern user interfaces, it doesn't really matter. Like, sure, you have a long list, 100 items, and so what, right? 100 items is already a lot. But the problem that where it really matters for us was we are building a note-taking app, and we ask you to write strokes, and strokes have oftentimes you could easily get like 10,000 stroke points on your canvas, and when we have a situation like that, it wouldn't be feasible anymore for us to adopt this sort of automatic version. And as a result, because most state management solution work well with Freeze, what you could immediately think of was that Freeze has this API called make collections unmodifiable false. So you would think that now you could be able to directly just add a point, right? But it doesn't work, because if you directly add a point and you return this, it's not going to be triggered, because this will always be equal to this. So you also have to add a force update flag, or any flag that you like. And every time you create, you add a point, you copy this object, and you add you change the flag, and so the equality comparison between the two would fail. And only under this you'll be able to trigger a force update. And it's kind of quite stupid that when you have to work around that much to get this effect. Also, you have to have additional allocation costs just to get this to work. So kind of frustrated with state management solution, and we sort of had to switch between all different kinds of state management solutions. We tried Flutter Block in the beginning. My friend came along and he felt basically Bridgecat came along and he thought a block was having way too much boilerplate. And we went on to Malbecs in Flutter. Malbecs has a lot of not be able to update stuff issue, and so we have some places where we thought it would be reactive, but it wasn't somehow. And then we migrated partially to Riverpod, and it was just a nightmare after all. Well, let me just go back. And the issue with state management also lies, if I could say, and this prints the time difference. So you see that these are the time difference when I add 10,000 points. They take 1 millisecond. I mean, this doesn't count the time to re-render the user interface, but rather the time to add those things. And this is clearly much slower to a certain extent. And so let's just close this. And I'm not even streaming, and I'm calling this stream.md. Yep, and I even called it steam.md. Whatever, we can deal with this later on. And the other problem when you were developing a software that you often face, and this is a bigger problem where I feel, is that oftentimes you have something called application state. Sorry, you have something called the user interface. And the user interface is trying to in sync, trying to be synchronized with the application state. So you sort of bear with me with my poor drawing skills on the text. So you're trying to synchronize this user interface and application state. And this is what actually a state management solution does. And and now with this application state, you also need to try to sync this with the database state. Right, so, and with the database state, you also need to synchronize with the remote state. Look at how many level, Markdown, you are so smart. Let me just try to fence this in code blocks so that they don't get messed around with. So when I save the things. And when you look at this, right, you realize that each level of synchronization between two things is very troublesome and requires a lot of code to be written. And the worst part is that oftentimes the states duplicate, or you have to duplicate sort of model. So for example, you have a preferences page for your models, right? You're going to write a model for your preferences, and you're going to try to, which is in the database state, where you store all the preferences flags that you want. And then you are going to make them reactive, meaning that you also have to develop a view model of that, basically containing the same field as what you would have in your database state. And you need to synchronize those two things. And then you also have an interface that will subscribe to the application state. And let me just here. So this is manage my state management solutions. And this is managed by what we would call as ORM, right? Object Relationship Mapper, Manager, or basically a manager for the database. And this is where ESR, etc. And this is basically the cloud SDKs. And the problem with that, your code would also have to be duplicated in the state management solutions, in the ORM, in the Cloud SDK. Let's take a very simple example. So say that you have a class preferences, right? And if you were to written it in ISAR, so you would have to annotate this with collection, right? And say that you only want to store like one preference or whatever, right? One preference class, and you need to make sure that ISAR only like has like this table of one element, and then you will have like a ID whatever, then flag bool flag 1, bool flag 2, bool flag 3, right? And then you will need to have like a state as well. So you have some sort of like some view model, and essentially some view model is just going to have a preferences under the hood, but it's going to provide something like a value listenable, value notifier, where like let's just say value listenable for us to listen to, and then bool and a flag, right? And I want to write more. And you want this value listenable, you also provide a set function, etc. Then basically it allows you to set the flags. And you're going to have a widget that subscribes to these things. And if you realize that there is nothing that additionally that you need from the preferences model in the preference view model, it is just that because they are using different standards, different formats, you need to sort of like write adapters, write glue code to make them work together. This is error prone, and this is like not effective. Basically leads to a lot of duplication of code. And like this synchronization, this is basically the synchronization being here. And if you write your custom backend, right, then this part you also need to handle it. So in the end, like the same sort of models has to be written like across like a different 3 different places, and you need to handle the like synchronization logic between those two things. And it's just annoying, and it's very, very, very error prone. So that is the initial sort of like intuition behind Dust. And Dust, we aim to sort of like unify all these things into one. So basically from application state down here, there are basically the Dust SDK. And when you build your interface, you directly interact with the Dust SDK like a normal state management solution. And you don't have to worry about the application state and the database state. And the synchronization is yet to be implemented, but that's where we are sort of. I did speak a lot. I need to drink some water. So yeah, like the second is like error-free like state management, and it basically prevents you from like making a lot of mistakes when you are doing like state management. We are still like in the midst of writing the docs, so installation, defining a model. It's not even updated yet, CRDT, and also like the docs that we provided will be based on what I'm working on today, which is yeah, that was already called Qinghai, but we realize it's way hard for you guys to pronounce it. Basically, it's going to be based on the freezed migration, and the freezed migration is this feature. We would want to implement a freeze-like API for Dust, so that it's very easy. It's basically saves a lot of boilerplate from your side for you to write. I guess I would like to pause this stream right now because pause this event right now before it gets too long, and I'll start a separate new video on like the migration to a freeze-like API, and I'm going to make a lot of mistakes in it because I'm not yet sure about how a lot of the migration is done, and I just like to sort of like get you guys involved in this process and in understanding what we are doing, and hopefully in this process learn from you guys.